In this lesson, we're going to be talking about surface area and volume of cones. So a cone is a solid with a circular base and a vertex that is not in the same place. So we have a circular base and then our lateral side meets at this vertex off the base. The altitude or height of the cone is perpendicular between the vertex and the base. So if you drop a line down to the base, that would be our altitude or our height. In a right cone, the height is going to meet at the center of the circle. So we're going to be looking at right cones to look at our surface area and volume today. And so on all of those, where this altitude comes down, this would be at the center of that circle that is the base. The slant height of a cone is the perpendicular distance from the vertex to the circumference. So what that means is that we take the vertex and we go down this side here, and it would be perpendicular, meaning it hits right at that circumference, but this is our slant height. So it's very similar to a pyramid, except that we're working with a circular base. So anytime we're working with circles, the distance from our center to the edge or to the circumference is our radius. So these are our three measurements that we're working with. So whenever we're talking about surface area, notice that this surface area formula is a lot like the surface area of a pyramid, except for the perimeter has been replaced with the circumference. And so since we're talking about circles here, we can go on and plug in those formulas. So the formula for the area of the base, which is a circle, would be pi r squared, and circumference is 2 pi r. So for a cone, the simplified formula is going to be pi r squared for the area of the base plus pi radius slant height from this 1/2 circumference times the slant height. So pi r squared plus pi r L for our circumference. For the volume of a cone, notice that it's the same. It starts out as the same formula as a pyramid, 1/3 area of the base times the height. And if we plug in our circle formula, that's 1/3 pi r squared times the height. So if we are looking to find the slant height, if we have the height and the radius, or if we have any two, thinking about our cone that we drew up here, notice that it becomes a right triangle in there from where our height is perpendicular to the radius in a right cone. So if we're going to need to find one of these measurements, if we have the radius and the height and we need to find the slant height, or any combination of two, we can use the Pythagorean theorem. So we would do the height squared plus the radius squared equals the slant height squared, because that's that right triangle that's created. So I've got my formulas written up at the top. For this first example, we're going to find the surface area and volume of each cone, but we need to follow the specific instructions for each one. So in example 1, it says to leave in terms of pi. So that means we need to multiply all the numbers around it, and then we'll come back and find pi. So to start out with my surface area formula, for a cone, that's going to be the area of the base, pi r squared, plus that 1/2 circumference times the slant height, which ends up as pi r L. All right, so looking at what we have here, 5 is going to be my radius, because it goes from the center of the circle out to the edge. And then since this is on the lateral edge of this cone, 13 is my slant height. So right now I have everything I need to find the surface area. I'm going to plug in what I know. So pi r squared, and my radius is 5. So pi times 5 squared plus pi times 5 times 13. And so to leave this in terms of pi, I need to find each of those number pieces, but I'm just going to leave the pi out of it. So for the first term here, I'm going to do 5 squared. So 5 squared is 25. So this would be 25 pi plus, next I need to do 5 times 13, which is 65. So 25 pi plus 65 pi. So to find my final answer, I just need to add these together, thinking about the 25 and the 65 like coefficients. So I'm going to do 25 plus 65, and I get 90. So the surface area is going to be 90 pi. Now to get my units, since these were measured in meters, and this is surface area, which is two-dimensional, so that's going to be square meters. So my surface area is 90 pi square meters. So now we're going to do our volume. And so the volume formula is 1/3 the area of the base, which is a circle. So pi r squared times the height. So I do not have the height of this cone yet. So I need to find it. Let's call this h. Here's my right angle because my height is perpendicular to that radius. So to set this up, I'm going to have my radius squared plus my height squared equals my slant height squared. So I'm going to plug in what I know. So 5 squared plus h squared equals 13 squared. So 5 squared is 25. And then I need 13 squared, which is 169. So to find h, I need to subtract 25 from both sides. So I'm going to do 169 minus 25, which is 144. That is a perfect square, so if I take the square root of 144, I get 12. So the height of this cone is 12. So now I'm going to plug that in. So 1/3 pi times 12 squared times my height. Oh, whoops. So not 12. The radius here is 5, so times 5 squared times 12 for the height. So to leave it in terms of pi, I just need to multiply these numbers together. So I'm going to do 1/3 times 5 squared times 12, which will give me 100. So this is going to be 100, and then I write the pi back. All right, so my volume is 100 pi. Let's put our units on it. So volume is three-dimensional, so that's going to be in cubic meters. For our next example, we're going to do the same thing, but we're going to use the pi button on the calculator instead of leaving it in terms of pi. So the things that I have, this 10 feet, that goes all the way across. So if I want to find my radius, which is just halfway across, my radius is going to be 5. Here, this is along the edge of the cone, so this is the slant height. And those were the two things that I needed for my surface area. So surface area of a cone is pi r squared plus pi r L. So I'm going to plug in the pieces I know. So the radius is 5. So everywhere I see an r, I'm plugging in a 5. And then the slant height is 12. So here, since we're using the pi button, once I have everything plugged in, I'm just going to turn to the calculator. I'm going to multiply all this together. So pi times 5 squared plus pi times 5 times 12. All right, so it says round to 2 decimal places. Let's go on and do that here. So I have 267.04. It's going to round up since that next number was a 5. All right, so for my units for surface area, that is square units, so this will be square feet. And then if we move on to our volume, that's 1/3 base times height, so 1/3 pi r squared h. So I have r, but I do not have h, so I need to find my height here. So I'm going to do radius squared plus height squared equals slant height squared. Plug in what I know. So 5 squared plus h squared equals 12 squared. Now these are squares that we found in the last problem. So 5 squared was 25. 12 squared was 144. So I'm going to take away the 25. So do 144 minus 25, which is 119. So h squared is going to equal 119. So whenever I find the square root of this, it's not a perfect square. I'm going to have to round. So let's go and round this one to 2 decimal places as well. So my height is going to be 10.91 when I round it. So now let's go and plug this stuff in. So my radius was 5 and my height was 10.91. So I'm going to go to the calculator with my pi button as my directions. So 1/3 times pi times 5 squared times 10.91. And that gives me a volume of about 285.62. And volume is 3-dimensional, so that is in cubic feet. All right, on this one, we're doing the same thing, but we're going to use 3.14 for pi, and then round to 2 decimal places. So looking at what we're given this time, this 4 is going to be my radius, 12 is going to be the height, so the thing I don't have here is my lateral slant height. So, let me scoot this up out of the way. Now, before I can even find my surface area, I have to have that slant height. So let's go in and do that first. So r squared plus h squared equals l squared. So I'm going to plug in the numbers I know. So I have 4 squared plus 12 squared. So 4 squared is 16. 12 squared is 144. All right, so 16 plus 144 is 160. So again, not a perfect square. We're going to have to round. So 160, the square root of that is 12.65. So whenever I round, I get 12.65 when I go to 2 decimal places. And now I'm going to use that in my formula. So for surface area, my formula is pi r squared plus pi rl. I'm going to plug it in. So pi times 4 squared plus pi times 4 times 12.65. So one thing I did not do here that I should have done is I need to plug 3.14 in for pi. So instead of those pi's that I wrote, I need to write 3.14 so that whenever I go to the calculator, I don't forget to use 3.14 instead of the pi button. All right, so now I'm ready to go and type it in. So I have 3.14 times 4 squared, and then plus 3.14 times 4 times 12.65. And so from typing all that in, I have 209.12. And this is going to be square units, so centimeters squared for my surface area. All right, and next we're going to do volume. So for the volume, that's going to be 1/3 pi r squared h. So 1/3 pi, I'm using 3.14. For the radius, I'm using 4. And the height is 12. All right, so now I'm ready to type this into my calculator. So 1/3 times 3.14 times 4 squared times 12. All right, and I get 200.96. This one only gave me 2 decimal places, so I don't have to round. So my volume is going to be 200.96, and this is going to be in cubic units. All right, so we're going to find the value of x here if we know the volume. All right, so the volume is 182. So my volume formula is 1/3 pi r squared times the height. And I'm going to plug in 3.14 for pi. 6 is my radius, and the height is x. That's what I'm trying to find. So I'm going to plug in the things that I know. So the volume is 182. And then for pi, I do 3.14. For the radius, I'm plugging in 6. And for h, I'm plugging in x. All right, so let's go in and multiply this stuff together so that we just have one number there in front of x. So that'll be 1/3 times 3.14 times 6 squared. All right, so now we have 182 equals 37.68 times x. So to find the x, I'm going to divide both sides by 37.68. So 182 divided by 37.68. And I'm going to round this to 2 decimal places. So x, the height, is going to be about 4.83. And since height is just a regular measurement, it's going to be in regular units. So that's 4.83 inches. On example 3, this triangle is going to be rotated about the y-axis, and that means in 3-dimensional space. So we're going to look at an example to help us visualize what this means. So in here we have our triangle, which is the same triangle from our notes, with vertices at the origin at 3 on the y-axis and 3 on the x-axis. So what we're going to look at is, since this is in 3 dimensions and we're picking it up and we're rotating it around the y-axis, what's actually happening is that there is another axis coming out to the side. So this is actually called the z-axis, which is our 3rd dimension. So here we see our x and our y, and then if we rotate it, we also have that z-axis. So we're going to take this and we're going to rotate it around that y-axis. And so as we do that, we're going to look at the solid that's created. So I'm going to take this, I'm going to rotate it. And so if you look on that 3-dimensional view, notice the shape that it creates whenever we rotate this triangle around the y-axis. So the bottom is a circle, and if we look at the other parts of it, notice that it comes up and a cone is created. So in this cone, this right triangle that we have, that represents our radius and our height. So the radius is going to be along the x-axis because that's the part that's rotating around. So if we can see here, kind of upside down. So this is just turned upside down. The green is the y-axis, and so that would be our height, and the red is our x-axis, so that would be our radius. So thinking back to this example in the 2-dimensional picture that we had, what happened was that it took this point and it rotated it around that axis to create a circle. And so in turn, that slant height also rotated around and created this cone. So this length is going to be my radius. So my radius will be 3. And this length is my height. And it kind of stayed in the middle there because that's where we were rotating. So my height is also 3. So we need to use that to help us find our surface area and our volume. So if we're looking at our surface area, that's going to be pi r squared plus pi r L, and I don't have L yet. L is this slant height. So to find L, I need to plug in my height and my radius into the Pythagorean theorem. So that'll be 3 squared plus 3 squared equals L squared. So that's going to be 9 plus 9 equals L squared. 9 plus 9 is 18. This is not a perfect square, and we're going to go in and round it to the nearest tenth. So the square root of 18 to the nearest tenth is going to be about 4.2 units. And then I'm going to go in and plug it into my surface area formula. So it doesn't tell me what to use. If it doesn't tell you, go in and assume that you're going to use the pi button. So the radius here was 3. And the slant height was 4.2. So it didn't tell me. I'm going to use my pi button. So pi times 3 squared plus pi times 3 times 4.2. And it says around to the nearest tenth, so that's going to make this about 67.9. So surface area is squared, so that's going to be square units. And now we're ready for our volume. So the volume of this is going to be 1/3 pi r squared h. So I'm going to plug it in using the pi button again. So I have 1/3 times pi times 3 squared times 3. All right, rounding to the nearest tenth, or the first decimal place, is going to be 28.3, and this is in cubic units. So whenever you see a triangle rotated around an axis, that is actually creating a cone.